Hello all and welcome to my YouTube channel. So today in this particular video I am going to be discussing about Detectron2 and object detection framework, which is developed by a Facebook AI research team. So this Detectron2 framework is actually helpful in for detecting and mask object detection or in normal object detection kind of task. So we have already have a different kind of object detection framework like TensorFlow object detection framework, YOLO framework, and such kind of frameworks are also developed in MXNet. But this Detectron2 framework has been developed in PyTorch framework. So backend of this Detectron2 is on PyTorch. So this all things comes around like the easyability and easiness of using this particular framework. So this is all about a particular framework which uses PyTorch, and the Detectron2 is very easy to use, and it is much more faster than TensorFlow prediction models. So if you go into this particular repo of Deuteron2, you can find that they have mentioned the capabilities what Deuteron2 can develop, it can give, such as panoptic segmentation, dense pose, cascade RCNN, point render, deep lat. So these all kind of models are available for Deuteron2, and you can directly use this using PyTorch or using Deuteron2, and they have already been used in particular scenarios where the objections are being required, and they are much faster than TensorFlow. So they even claim it like it trains much faster than any other frameworks. So you can go over this repo of Deuteron2 and understand the basic things. But in this tutorial, I am going to be walking through the basics of Deuteron2. We are not going to train a custom model on Deuteron2. We're going to be doing it on later classes. But for this particular tutorial, I'm just going to be getting into the basics of Deuteron2, like what it is about and what are the models it includes. And we're going to do the just inferencing part of it. We'll take a pre-trained model and we just do the inference on it, and in the next upcoming tutorials we're going to be taking up the custom training of Reatron 2 models. So in this particular GitHub repository, you can find many of the things. So you can find the installation instructions. So if you click on this link, you can find the instructions. So these are pretty much very easy instructions you can follow, and you have to be sure like what are the torch versions you are using, that is PyTorch versions you are using, and with respect to that you have to install CUDA. And similarly, there are some common issues there while installing, so you have to come over here and understand it, like what are the issues, and you can have to clarify it using Google, or you can come over here and understand it. So this is what the installation is all about. I will do give you a code and all so that you can understand how the installation is done. But that will be pretty much simple. So we'll be doing it on Collab notebook. So I think that would be very easy. But when you come to the local environment, so you have to be taking care of these instruction guidelines. And you can get into this particular tutorials also. They have good documentation. So if you click over here, you can get into documentation of Detectron2, and these are the different kind of capabilities what they even explain it, and different kind of classes what they include in Detectron2 framework. And there are models which are going to be included in Deuteron2, so you're going to be going through it. So let's click through the model zoo. So these are the models which are available inside this Deuteron2. So you can see faster RCNN, RetinaNet based model. So faster RCNN has many kind of models in it present. RetinaNet also has many kind of models available. Even RPM and faster RCNN also have many kind of models. So there are many kind of models available. Even for mass RCN it is available. So such kind of models are available with different learning rates. So if you see, here's the learning rate column, and you can see it's 1x, 3x. So they're a lot faster also. Some models are little less models have less learning rate, but they are performing. They take much time to train. So that's the approaches. And if you have faster learning rate, so obviously the model will take less time to converge to the accuracy or training time, and inference time is also getting varied according to that. So this is how I generally see while selecting a model. So I generally see which model is a lot faster and which model with lot of fast which has lost a lot of fastness with good accuracy. So if you have a better AP, that is average precision of a model, more than 40, then we consider as a good model, or if it is near to 30 percentage, then we say it as a very decent kind of model. So that's how the approach should be. And you have to also see the training time, how much time does the particular training of a model is taking while doing the training. And even you have to take care of this GPU memory. So if you consider this particular model, so it takes 3 GB of your GPU to get it trained. So you have to consider these factors as well while setting any kind of model from here. So let it be any retainer net or any faster RCN or RPN, but you have to make sure that you have to take care of this particular parameters and then select a model according to your training criteria. So this is the number of models, and there are a lot of categories available in this particular Detectron2 available models. But you can also select any kind of model, and you can just do your inferencing part of it, and you can train a custom model and work with it. So there is no issue. And PyTorch is one of the best libraries available, which can help you to train a model in a better efficient way. TensorFlow also has these kind of models, but they are very less efficient. They take a lot of time to get trained. But faster RCNs and other kind of model do take a little less time in TensorFlow. But if you see overall comparison of Detectron2 and TensorFlow object detection models, they are pretty much less fast than PyTorch models. So these are the things you have to take consideration while checking the Detectron2 models. And let's get back to the GitHub repo. So this is what all GitHub repo has in it. And now let's get back to the tutorial part of Deuteron 2. So this is the collab notebook which is being given by the Deuteron 2 team. So I'm using directly that. So we can just do the inferencing part, and later tutorials we're going to be training a custom model for for training with Deuteron 2. And so let's start with the installation of Detectron2, and like let's see how we're going to be doing this. So first you need to import the torch, and you need to check like what is the torch version available in your Colab environment. So according to that you have to install Detectron2. So in your installation instructions mentioned in over here, it is clearly mentioned that for particular torch version you have to install CUDA, particular CUDA, and according to that you have to get the Detectron2 installation files. So right now I have a 1.9 torch installed, or at it 1.9 version of a torch installed, and with CUDA 10.2. So this is the configurations I have in my Colab environment, and with respect to that information, I have to install particular torch version in it, or particular Detectron2 version in it. So for this, after seeing this particular step, we have this particular PyML file, which PyML library, which we're going to be installing it, because most of the time we're going to be working with YML files only. So we have to have a library which is able to handle all those YML files. So PyYML file is one of them. So you can use this particular library, and which is also provided by the Facebook AI research team to use it. And then we have to install Detectron2. So you have to just give a command pip install Detectron2 with this particular link, and with respect to whatever the torch version you have, you have to specify it over here. So suppose if you got a torch version like 1.7, 1.6, so you have to just make sure that you have to remove this 1.9, and you have to add 1.7, and that particular version of your Detectron2 will be added in your particular Colab environment. So right now I have 1.9, so I will go and erase and write it 1.9, and install a Detectron2 version of 1.9 torch version. So everything should be installed with respect to torch version, and once this installation is done, we can proceed with the next steps for inferencing. And for me everything was already satisfied, so it wasn't that it didn't took much time for me, but it could take few minutes to install. So once the installation is done, so this is the check of the installation what we have done. So checking of the version is done over here. So let us run this. So it says, yeah, we have a solution of this particular, and it says true. And once this installation is ready, we can just take a basic import from the Detectron2. So in this particular import, we are directly importing Detectron2 framework, and from Detectron2 framework, we are using utils.logger to import setup logger. So this particular class will help us to log or get the logs of the particular training or particular inferencing of whatever we're going to be doing with particular Detectron2. So whatever the inferencing informations and whatever training information that is getting printed, it will be taken care by this setup underscore logger. And then we're going to be importing numpy, os, json, cv2, random, and then this cv2 im show from google.collab patches. So these are just the general imports. And from Detectron2, we're going to be importing model zoo, because we are going to use model zoo models. So we have to import it from Deuteron2, and we are going to use Deuteron2.engine import default predictor. So right now we are going to inference up a model, or we're going to take a particular replicated model and do the inferencing on it. So default predictor class will help us to predict the results. So this will help us to get the inference of the results. So this is the class which is going to be used for the inferencing. We have one more class which is called default trainer, which will be used for the training of a particular data set. So that will be taken care in another tutorials, like when we're going to be training a custom data set. But for now, we're going to be using the default predictor. And then from Detectron2.config, we are going to be importing get config. So for every uh, models which are available in model zoo, so let me show you over there. So if you see, these are the models. So if you go to the faster RCN menu, we have this model. So for every kind of model, we have one configuration file associated with it. So if you see, this is the configuration file which is in YML. So we have to check, or we have to get this particular YML file by using this particular function, which is called get config. So for every model, we have configuration files, like what are the model and what is the information of models, what are the weights. So these are the weights information which are being stored in YML file for particular model. So that particular information we need to extract. So that thing is taken care by this get underscore config file or function. So it is associated with every kind of models. If you go into this R50DC5, so you can see this is the configuration file just for this particular model, and you can see this is the weights, and this is the base model link, and these are steps, maximum iterations, depth, so and a mask on false. So these are the information present in YML file. So this is what the information a configuration file consists for this particular model, which is R50DC5. And in the next import, we have Detectron2.utils.visualizer. So visualizer class will help us to bounding box the information which is present in the particular image. So it will help us to draw a bounding box around the identified objects. So this class will directly help us with that. And Detectron2.data imports metadata catalog, dataset catalog. So these are information required when we do for the when we go for the custom training. So once this imports are understood, then we can just run it, and we can proceed for the inferencing and loading of our pre-trained models. So for getting the inference of for loading of a particular model, we'll just take a particular image, and we'll just show it up over here, and it will take few seconds to download this particular image and get this image downloaded in this collab environment. So this is the image, and we're gonna pass into this particular pre-trained models, and we get the inference from it, like what are the objects being identified. So for detecting the objects, we're going to be using this get underscore config, and this is the function. This is the class we're going to be loading in CFG variable. And once this CFG variable is initiated, we'll take a method from this particular class, and that is merge from file, and from model zoo get configuration files for a particular model. So for this tutorial, what Now we are taking is masked RCNN R50 FPN 3x model. So if we go into the model zoo, and if we go into the model zoo, we have masked RCNN. We have masked RCNN. Okay, here it is masked RCNN, and then what kind of model we have? R50 FPN 3x. Okay, so R50 FPN 3x. So 3x is nothing but a learning rate scheduler. So we have this model over there, and we are passing the YML file of it. So we are just passing the path where it is being stored in a particular GitHub repository. So we are passing this particular path from here to here, and we are copying and pasting it over here so that it can load all the configuration files present in this model zoo folder. So now it is taking and merging into this configuration settings, and then we are taking the model and we are setting up the threshold of it. So right now I have set 50% threshold. You can change it to 70%, 80% according to your needs. But for now we are taking 0.5, and then we are specifying the model weights. So in model zoo.get checkpoint URL, we have model weights of it. So it should be, it is generally stored in this particular YML file. So if we go into this YML file, we have this model weights. So we want these weights. So we want these weights to be stored in particular configuration files. So we are again passing this particular path, the same path which we have passed above, and we will just get the model weights. And once this settings are being done, then we'll take a default predictor class which will be used for the inferencing, and we'll pass this configuration function into this default predictor class. Once this predictor class is set, we can pass this image, whatever the image we have, into this predictor class, and we can get the outputs. So this is what the whole step is about. We just initiate the configuration files, we pass the YML files, and we set up the threshold. Then we again pass a YML file to load the weights, and then we use default predictor to set up the configurations in particular predictor class, and then we pass the image to that particular predictor class, and we get the output. So this is what this particular cell is doing. So let's just run this particular cell. So once this thing get initiated, we'll start seeing that it is downloading this particular masked RCN model with R50 and FPN 3x. So you can see it has started downloading the model. So it is quite heavy model. You can see 178 MB, and it will take few seconds to get downloaded. And once this download is being done, we can just run this particular cell. So you can see this is the output it's gonna be taking here once it runs on this particular image. And output has dictionaries. Output is a form of dictionaries. So we are just taking the instance from its particular output, and we are taking the predicted class, and we are taking the predicted box. So let's run this. So it is printing the classes of it. That will be in the form of indices, and this is the particular bounding box where it has detected. So now after this detection and the class output uh, has been shown up, now we'll use visualizer method or visualizer class to just showcase whatever the output has been printed on this particular image. So we'll run this particular cell, and we'll see the bounding box all over the images. So you can see, since we have passed only masked RCN into this, so it is dating the mask also with the particular object action. So this is what it is doing. It has identified the person, horse, person. So this is what the visualizer is doing. It is just marking this particular bounding box with this particular color, and you can see these are different person with different color. So you can see different person with different color. So this is what the particular visualizer is doing, and it is also masking this particular thing. So masking means it is actually detecting the object with this particular rectangular box, plus it is also giving this color to identified object. So this is what a masking is all about. So faster RCN with masking, so it is called mask faster RCN or fast RCN. So this is the model which we have used. You can also change the configuration files over here. You can go to this model zoo and you can select any other files. So if you go into this particular file or this particular model zoo, you can go into this particular let's say uh, R50C4. We go into this and we just take this particular path, we copy it, and we pass into this uh, particular configuration files, and we just change this particular things, and we just start loading the model. So we'll run this. So we have changed the model now. It should not detect only the objects, so it shouldn't be doing the masking now, because we have changed the model to faster RCN. So mask RCN has been removed. We are just now using the object detection model, which is faster RCN. So it will take few seconds to download, and once the download is complete, we'll again run this particular inference on our image, and we'll see the output of it, like whatever the predicted does and bounding box it has produced, but this time no masking will be there. So let us run this particular cell again, and let's visualize the output. So it would take few seconds. So now you can see it has not marked any masking, because we have changed the model to fast RCN, and it is not just pointing out the bounding box. So this is how you're going to do it. This is how you take the inference and do it. This is how you change the files path, and you can just work with this particular Detectron tool. So this whole tutorial was about just understanding the GitHub repository, what are the information we have in Detectron2, and how we can do the inferencing. We like how we can understand the model zoo, what are the things in model zoo, and how we can install this. So this tutorial was about all these things. I hope you like this. If you like my content, please do subscribe my channel. Thank you.